How do you prevent off-by-one loop errors in your code? Imagine writing a loop that skips the last item or processes one too many. Off-by-one errors can cause bugs that are tricky to spot. They happen when your loop runs one time too many or too few. This is often because of incorrect boundary conditions or how you count your items. To stop these mistakes, start by understanding your loop boundaries clearly. Decide if your loop should include the start and end points or exclude one. For example, if you have an array with 5 items and you're using zero-based indexing, your loop should run from 0 up to but not including 5. That means your loop condition should be less than the length, not less than or equal to. Next, keep your indexing consistent. If you decide to use zero-based indexing, stick with it everywhere in your code. Mixing zero-based and one-based indexing can cause confusion and errors. When writing your loop conditions, prefer strict inequalities like less than or greater than instead of less than or equal to, unless you need to include the boundary. Simple conditions are easier to verify and less likely to cause off-by-one mistakes. Always test boundary cases. Check what happens at the very first and last iterations. For example, test with empty arrays or single-element arrays. These tests help catch off-by-one errors early. Use descriptive variable names like startIndex, endIndex, or length. Clear names help you keep track of what each variable represents. Take advantage of language features. Many programming languages offer built-in functions or constructs like range-based loops or iterators. These tools handle index management for you, reducing chances of mistakes. Before accessing array elements, verify that your indices are within valid bounds. This simple step prevents out-of-bounds errors caused by off-by-one mistakes. Regularly review and refactor your code. Code reviews can reveal subtle off-by-one errors. Refactoring helps clarify your loop conditions and makes your code easier to understand. By following these practices, you can write loops that do exactly what you intend. This reduces logical errors and makes debugging much easier. Preventing off-by-one errors is key to creating reliable, bug-free programs that behave as expected every time.